Alright, so we're going to get started. So I'm going to share my screen with you. Let me open that up. I'll do this one. So you should be seeing, there we go, it's going. My paper should be. If at any time it disconnects, let me know, or if it stops sharing, again, let me know. Sometimes that happens. But here, so let's get started. This is what we did yesterday, Joseph, regarding the outliers. So we're going to start with that. Make sure that we understand how to find our outliers and if we have one based on a given data. Okay. So we're going to do the first one. It's very similar to that. Let me make it bigger so that we can easily read it. So we have our data. So remember, first you must always put your data in increasing order from least to greatest, in numerical order, however you want to call it, but it's always from least to greatest. So making sure the data as is right now doesn't really help us unless we rewrite it. So the smallest number on our list is the number 6, so we'll start there. Write down the number 6. Next up, we have the number 10. The next number then, we have the number 12, and we have 2 of them. Good morning, Brianna. Then we have 2 number 13s. So you got to make sure if there's 2 of them, write 2 on your list. A number 14 and a number 16. So I have 1, 2, 3, 4, 5, 6, 7, 8. Have to make sure that you have all of them. Sometimes you can forget one. So 1, 2, 3, 4, 5, 6, 7, 8, 9. I forgot one. What did I not count? Oh, the number 22. So yeah, make sure you double count them. So now outliers. Remember that for outliers, first we need to find, it helps to draw that box plot in order to then find your outliers, depending on that. So this, remember, this number 6, this is your minimum, your min. The number 22, this is your max. Then here we find our median. Median is that middle number. One of the ways to do that is by crossing off or counting into the middle. So 6 and 22 coming in from the ends, 10 and 16, 12 and 14, 12 and 13. Our median then is 13. So now the lower quartile, the lower end, we find the median here, the number in the middle. So now let me do a different color, 6 and 12. Now the middle of 10 and 11, the number that's in between 10 and 12 would be 11. So here then we have 11. Now the median of the upper quartile. So we have 13 and 22, not including this median 13, okay? So 13 and 22. And then the middle number, so what's in between 14 and 16? So in this case, it's 15. Remember, another way, if we don't know what's in between, is to add the numbers and then divide by 2. 14 plus 16 is 30. 30 divided by 2, we get 15 as well. So now we can sketch our box plot. So our min is 6, our max is 22. So let's do every 5. So 5, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25. So starting with the min and the max at 6, that's our min. At 22, that's our max. Our median, remember that middle number is at 13. Our Q1 is at 11, and our Q3 is at 15. So there's our box plot. Now we can find if we have an outlier. Remember, for an outlier, if any number is less than Q1 minus the IQR times 1.5. So those are formulas that you guys should be familiar with. If any number is greater than Q3 plus the IQR times 1.5. So now the interquartile range, remember that IQR is equal to the inner quartile range. How do we find that range? So for that range, it's Q3 minus Q1. So in this case, Q3 is 15 and Q1 is 11. So the median of your lower quartile and the median of your upper quartile. So to find our IQR here then, 15 minus 11, or IQR for this problem is 4. So keep it in mind, this is based on the data set that you have. So your IQR is always going to depend on which numbers you're working with. So for this example, it's 4. So now here, Q1 is 11 minus the IQR, which is 4, times 1.5. On over here, Q3 is 15 plus 4 times the IQR, which is times 1.5. So now this is where we would use our calculator. Let me see if I can share that with you. And they also give you a calculator in Edgenuity. Let's see if you can see that. Is it sharing? No, huh? I don't think I see it. Okay, so let me... I don't know how to... So I'm going to stop sharing that so that I can now show you my other entire screen. It should share soon, so let it load. But now you should hopefully see everything there. Hopefully. Now you should be able to hopefully see the calculator. So now, whenever we're doing this part, first we need to do the multiplication. So we have 4 times 1.5, so that we have 6. So it's 11 minus 6 and 15 plus the 6. 11 minus 6, here we get that 5. So any number that is less than 5 is an outlier. Here, 15 plus 6, 21. Any number that's greater than 21, we get an outlier. So that's how we know if we have an outlier or not. So now we go back to our data set. Do we have any number less than 5? No. 6 is greater than 5, so 6 is fine. But here, any number greater than 21, meaning that 22, which is greater than 21, that is our outlier. Okay, so that's how we go about finding our outliers. That's why there's a process to it. I know it does take time, so make sure you take your time doing it. But you'll see that once you actually do it, hopefully it shouldn't be that difficult. If it is, let me know. We can go over another one. But make sure, first thing whenever you're doing these, write your data and increasing order. So from least to greatest. You'll see that, let me close this here. In the problem that they gave us, There was no specific order to it. They just gave us the data set, and then we go from there. So first, make sure that you write your numbers from least to greatest. Once you do that, make your box plot. First, find your median. Remember, median, that middle number, your min and your max. Then find the median of the lower quartile, which would be your Q1. Then the median of your upper quartile, so the upper half, which that is your Q3. Then we have these formulas. If you don't have these formulas in your notes, make sure that you have them. Let me highlight them for you. So x, if any number, remember x is just a variable, if any number is less than Q1 minus the IQR times 1.5, then that would be an outlier. And if any number is greater than, remember that this is for greater than Q3 plus the IQR times 1.5, then that number is an outlier. Okay, because remember, you can have outliers on both ends. So either at the lower end or the upper end. And remembering also, if you don't have this in your notes, the IQR, that stands for the interquartile range. So we're looking at the range from Q1 to Q3. And if we look at the box plot specifically for the IQR, we're looking here. This is the range that we're looking at in the highlight. So from 11 to 15, which would be 4. So that's how we get this 4. So hopefully that reviews everything, because you guys do have a test coming up if you haven't taken it yet regarding outliers. Now for normal distribution, or for, let's do this one here before we go to normal distribution. I'm going to move this. So the next one, number 2, if a new data point at 12 is added to the graph, which is true. So here we have our graph. We're going to add a new point at 12, meaning it's going to shift. So first, if I add the 12, we see here, currently our range is from 1 to 5. All of our points are in between 1 and 5. Now, if I were to add 12, we see that 12 is way over here out in the right, which will likely be an outlier. We haven't solved for it yet, but we could say it's likely going to be an outlier. Now, when we do this, the median will change, and not only that, but the mean. Remember that the mean, and let's do this then. Let's find the median and the mean for this dot plot. So we have one number at 1, 3 dots at 2, so that means we have 3 number 2s on our list. 1 dot at 3, 3 dots at 4, so 4, 4, 4, 4, so 3 4s. 1 dot at 5, and now we're going to add a dot at 12. So let's ignore this 12 at first. We want to find the median and the mean. Remember that for the mean, we add up. Let me make sure you can see that. We add up all of our values. And then divide by the amount. So at first, without including the 12, 1, 2, 3, 4, 5, 6, 7, 8, 9. We have 9 points. Let me double check. 1, 2, 3, 4, 5, 6, 7, 8, 9. So we're going to divide by 9. So now bring up our calculator again. We're going to add these up. So let me clear that. So 1 plus 2 plus 2 plus 2, we have 3 2s, plus 3 plus 4 plus 4 plus 4 plus 5. So we have 27. 27 divided by 9, if you don't know your multiplication facts, but that's 3. So our mean, without including the 12, is 3 as of right now. The median, that middle number, remember, you work your way in from the end. So 1 and 5, 2 and 4, 2 and 4, 2 and 4, Our median is 3 as well. So now we need to do our mean, but this time include the 12 so that we can compare them. So it would be the same, that 27 plus 12, but this time divide by 10. Or if that 27 I'm bringing from the previous one, and we're just going to add the 12, but we could also see it this way. It's 1 plus 2 plus 2 plus 2 plus 5, plus 3 plus 4 plus 4 plus 4 plus 5 plus 12, and divide by 10. So this time we're including the 12, so that's why instead of dividing by 9, now we have 10 values. Okay, we knew that all of this was already 27, so that's why it's the same as 27 plus the 12 over 10. So now going to our calculator, it's showing still. So 27 plus the 12, 39, divide by 10. So in this, our mean here is 3 and 9/10. So you can see that it's increased. Now our median is that middle number. So including the 12 now. So working our way in 1 and 12, 5 and 2, 4 and 2, 4 and 2. And for a median, we're left with 2 numbers. So remember, we take both of them, we'll add them, divide by 2. So 7 divided by 2, 7, sorry, let me clear it. 7 divided by 2, why is it not? 7, 9. There we go, 7 divided by 2, 3 and 5/10. So once again, when we compare them, it's increased. So whenever you have a dot plot like this, remember that each of those dots represents one of the numbers within your data set. So make sure, I would recommend, write down all those numbers and then find the mean and find the median and compare them to see what's happening. So by adding that 12, how I said it's likely an outlier. We haven't solved for it yet, so we can't say that. But if we look at the numbers that we had at first, it's way off that number 12. So find the mean. Remember, the mean, you add up the numbers and you divide by the amount of values that you have. So at first we only had 9. When we added that 10, that added a value. So that's when we added that 12, that added a value. So that's why the second time around we divide by 10. The median, remember, median is that middle number. You don't have it in your notes. The third one, mode. We haven't gone over mode, but remember, mode is the most. So the value that appears the most within your data. In this case, the number 2 appears 3 times and the number 4 appears 3 times. So your mode would be 2 and 4. Mode the most, the one that appears the most on your list. So these are the 3 measures of center that they've gone over so far. Okay? Is there any questions there? If there is, unmute yourself, let me know. Welcome, Kayla. Now, regarding standard deviation, I'm gonna ignore this for now. Let me make this bigger. I want you to look at my paper. So regarding standard deviation, or what we also call sometimes, they might have referred to it in your lesson as normal distribution. So normal distribution is bell curved, and it looks something like this. I'm doing my best to draw it. And then we're going to label the parts of it. So we have some kind of a bell. So if we were like to draw a bell, you see that here we have something that looks like a bell for normal distribution. Mine's not perfect, but it's something like this. Within your normal distribution, I'm going to draw the parts for you. This here, if it's normal, perfectly in the middle, we have your mean, or what we also call sigma. No, this would be 0, sorry. But your mean. Then from here, we work our way out. So one normal distribution okay. So here, this going from the mean, if we add one standard deviation, we end up here. Since it's to the right, it's adding. To the left, then, if we subtract one standard deviation, we end up here. What this tells you is where most of your data lies. What this here, 34% of your values of your data are here. 34.1%. Here on this side, 34.1% of your data lies there. Again, this is looking at data that they're giving you. So if we look at within one standard deviation, if we add 34.1 and 34.1, 68.2% of your data will lie within one standard deviation. What standard deviation is used for is to compare a general population. So for example, when you take like the CASP, or when you take any kind of standardized test like the SAT, the PSAT, a standard, it's normalized, and then it's broken down into like, okay, where is it that you lie? Are you within the general population, or are you either that's how we look at these. So are you, the mean would be the general like the average, everybody, this is where they scored. And then from there, everybody is compared to that. Okay, so that's when we use these. So 68%, you see that's more than half. So the majority are within one standard deviation. Now, if we extend it to 2 standard deviations, so if we add 2, and also if we subtract 2, this here represents 13.6% of the population, as well as this side, 13.6%. So now, within 2 standard deviations, we're going to add that part. So from here to here, then, if we add those up, let me bring the calculator so we can see it together. Okay. So 13.6 plus 34.1 plus 34.1 plus 13.6. You will see that that's the majority of the population now. Within 2 standard deviations, that's 95.4% of all the values. Now, when we get to 3 standard deviations, which is very rare, but when we get 3 standard deviations, so now, again, to the right, we would add 3 standard deviations, and then to the left, we would subtract 3. This here, this area, represents 2.1% of the population. And then again, to the right, left, 2.1%. So now adding that to the total, so now we're going from here to here. Again, adding that up. Sorry, so you could see that. Let's start. Let me clear this so we could start all over. So we have 2.1% from here, plus 13.6%, plus 34.1%, plus 34.1, plus 13.6, plus 2.1, and our total, we get 99.6%. So that's pretty much about everybody. So now, what about beyond 3 standard deviations? So beyond 3 standard deviations, it's very rare, but we like to say that this is 0.1% and 0.1% because it's possible to do that. But how I said, for normal distribution, we do these when we're comparing a large population, and we usually do these when we have a standardized test, meaning that it's a test that's taken by a large amount of people, and it's also taken within the same environment. So meaning, like, for example, whenever you take state tests, you might remember that everybody has to sit a particular way. Everybody is read the same instructions. Everybody gets the same booklet. You might not necessarily get the same questions. They might be mixed in order, but you are all tested for the same thing. So that's how it works, that everybody's tested equally and given the same instructions, the same amount of time, because that's part of that takes also that gets taken into account. Gets given the same amount of time, even the same pencils, that all goes into it. Because then we want to compare everyone based within the same environment. How do they do? So whenever we take these standardized tests, sometimes we're comparing scores not only within the school, within the district, within the state, even within the country. Like for the SAT. The SAT is taken worldwide. So it's compared internationally. So we have even more data that way. But then it's broken up into this bell curve. Here, I'm just using placeholders to show you where most of the population would be. Most of the population is here. And that's where we get this, like, if you want to think about the bell, most of us are within the bell. And then as we're going outside of it, it's less and less. Okay? But it's also based on that mean. Remember that the mean is your average. So it goes from the average. You're either going to be above the average or below the average. Okay? I hope that helps clear some of those videos you've been watching, but let's go over one of the problems that I wanted to go over regarding this. Yeah, because remember with statistics, all that you're doing is you're comparing information. You're either comparing people, you're even like here, for example, each person counted on a walk after a rainstorm. So how many people are walking? We're either counting or doing some kind of thing. Now regarding the word variance, let me pull this up. Give me a second. So here we have our standard deviation. So one of the ways, and I think I talked with you, Brianna, about this one the other week. So here, the mean of the score is 75 points. So we're going to draw some kind of a bell curve, and let's label it. We don't know much information. We just know that the mean, so right down the middle, our mean is 75. Amy's score was 67, which was 2 standard deviations below the mean. So 2 standard deviations. So meaning 1 standard deviation, 2 standard deviations. Below, meaning that it was less than, below the mean. So we want to know what was the variance. So if we look at where she's at, 67, that might not help. Yeah. So we want to see, she's, 2 standard deviations. So let's do 67. We want to find out, well, what's 1 standard deviation? That one. So one of them from 67 to 65, let's find the difference. So 75 minus 67 to find a way, how far apart are they? So subtract, I need to borrow from the from 7, make it a 6 in order to be able to subtract. 15 minus the 7, we have 8, meaning that each of these is 4. Because they're equally spaced. I think I forgot to tell you. Then the standard deviations are equally spaced from one to the other. So up here, keep that in mind also, they're equally spaced. So from the mean, one standard deviation, it's 4 apart. So if I subtract 4, we have 71. And then from one standard deviation to 2, subtract 4, we get 67. We can even do 3 standard deviations. We subtract 4 again, and we would get 63. Meaning we could also go this way so that we can practice. So one standard deviation, we would add 4 if we're going to the right, because now it's greater. So adding 4 is 79. For 2 standard deviations, add another 4. So we're at 83. And for 3 standard deviations, add another 4, we're at 87. Which makes sense. Most of the scores, remember, this is a test that she took, right? Most of her scores were probably between 63% and 87%. And we'll look at 63%. That's right above a D. 87%, that's at a B plus, meaning that very little students probably got an A, and very little students actually failed. So most of the students passed within that one standard deviation. So most got between a 71 and a 79, which sounds reasonable, meaning that most of them got a C. And then from there, some of them got a B, some of them got a D. But most of the class passed and got a C, looking at the points that way, out of 100. So now variance. Variance we know that one standard deviation is 4. Variance is your standard deviation squared. So 4 squared is 16. That's how you find it. First, you need to find your standard deviation. And in this case, it's equal to 4. So how far apart is one standard deviation from the mean? Then you take that number and you square it. So that's how we get that 16. Okay. How are you guys doing? Does this make sense? Hopefully it summed up your videos, because you guys do have a test coming up. If it didn't, let me know. But I'm gonna stop there for now. Let me stop sharing.